Okay, welcome to today's class on number systems. What is number systems basically about? So number systems help us so that we can write numbers in different forms or different bases. Okay, so we are basically going to do with how we can convert or represent numbers from one base to another base. There are several bases that exist. We have base 2, base 3, base 4, base 5, base 6, base 7, base 8 till yes. So there are several bases that exist, but then the four most popular bases we are going to use are, we are going to consider the binary. Okay, binary, that's what we are going to use. And then we also have the decimal. Okay, so we have the binary notation, and then we have the decimal notation. Then we have the octal notation. And then we also have the hexadecimal notation. So these are the four bases that are used often. So we learn how we can represent data or numbers in any of these bases. So if you have a number that is in binary, you want to convert it from binary to, let's say, decimal, or you want to convert it from decimal to hexadecimal. So we are going to learn how to change in between them. So we have binary, we have decimal, we have octal, we have hexadecimal. We'll learn how we can convert from binary to decimal, from decimal to hexadecimal this way. Then we'll also learn how we can convert from decimal to binary. So we'll also go this way. Then we also learn how we can convert from decimal to octal and from hexadecimal to binary. So that's basically what the study of number systems is about. So let's see something. Now, for binary notation, in binary notation we present numbers in zeros and ones, okay? So digits that are only zeros and ones. So zeros, let me write that here. So for binary notation, we represent numbers using zeros and then ones. Only zeros and ones. So binary means that you are working in base 2. Okay? Binary means that you are working in base 2. So the trick or the secret here is that if you are working in a particular base, you don't write, you always use numbers that are lesser than the bases, up to 0. Okay, so for all of them, we'll begin from 0. So decimal means that you are working in base 10. Then octal means you are working in base 8. And then the hexadecimal means that you are working in base 16. Okay, so for all of them, we'll begin from 0 to... So for all of them, we'll begin from 0. But then the digits that are allowed, or the digits that are permissible, that you can use for calculation in a particular base, those digits are always lesser than the particular base you are working in. What I mean is that since binary means we are working in base 2, to know the kind of digits you can use in working binary digits, you use numbers from 0 up to 1. Because we don't use either 2 or a number above 2, but we use from 0 to the number before the base you are working in. Okay, the whole number or the positive integer before the base you are working in. So base 10 to we use from 0 up to 9. So you go one step below 10, and from that number to 0, all those numbers are permissible. Okay. Now for base 8, can you guess that? So we use from 0 up to 7, because 7 is the whole number or the positive integer that comes before 8. So for these two, up to 15, right? So for the hexadecimal notation, we use from 0 up to 15. Now, let's move on. So this is the basic understanding we are going to derive for this. Now, the numbers that are used here, for the zeros to ones, we call them bits. Okay, the zeros to ones, we call them bits. That the bits means binary system. Okay, good. So we also have the decimal, the octal, and then the hexadecimal. Now there's one thing that we need to take note of. That is, it becomes more easier whenever you have to convert from, let's say, one base to another. Maybe you have a number in the hexadecimal form, or you have a number in the octal form, and then you want to convert it to, let's say you have an octal notation, you want to convert it to hexadecimal. One of the easiest ways you can do it is that always try to convert it from octal to binary. So if it is in octal you want to convert to hexadecimal, first convert to binary, then convert from binary to hexadecimal. If it is in hexadecimal you want to convert to octal, first convert from hexadecimal to binary, which is very easy, we'll be doing that. Then from binary to octal. You can also convert to hexadecimal. So we'll quickly look at how to do that. But before we do that, let's realize this, that for the numbers for the hexadecimal, the permissible numbers are 0, 1, 2, 3, up to 9. For 10, we don't write 10 like that. We represent 10 with A. Okay? Then 11, we represent 11 with B. 12, we represent 12 with C. So let me write it here. So for the hexadecimal, A is 10, B is 11, C is 12, D is 13, E is 14, then F is 15. So you see a number, an example of a number in hexadecimal is something like EE6, base 16. So this is a number which is in the hexadecimal notation. How do we know that? Because we have E here, we have E, but we know that E is equal to 14. So when we are solving this, we are going to represent E with 14, then we solve that. Okay? Another example we can take, I think we solved some examples. We have a number like maybe A2DF. A2DF base 16. This is also another number in hexadecimal. So whenever you have any number at all and you see alphabets in the number, that number is hexadecimal. There are no two ways about it. Okay? Good. So for you to know whether a particular number is in this or that base, when we have a number like maybe 11 base 2. So usually the base is written as a subscript. Okay? So if the base is written as a subscript. Okay, so the base is always written as a small number here. So we can have 111 base 2. This is a number which is equal to 7 in base 10, but this is 111 in base 2. Okay, that's good. So the base is always written as a subscript. Another name for base is called radix. Another name we can use for base is radix. So let me write that here. So you will be using that more often. So base, another name for base is radix. Okay, another name for base is radix. Okay, good. And it's also very important to keep in mind that the base, when you see anytime we talk about base, we are referring specifically to 0 and 1 and no other number at all. Okay, we are referring specifically to 0 and 1 and no other number at all. So it's very good that we keep these things in mind. So one last thing I want us to consider is the number of bits that we need, or the number of bits that we require to be able to represent a particular number in either hexadecimal, the octal, or the octal or the binary. So you know hexadecimal is 16, right? Base 16. Hexadecimal is base 16. Now 16 can always try to write the 16 in the form of a base and then an exponent, okay? So 16, where the base is specifically 2. So 2 exponent what, or which powers we raise 2 to so that we get 16? That is 4. What this means is that we need 4 bits to represent a number in base 16. That's what it means, that we need 4 bits to represent a number in base 16. If I say 4 bits, I mean the bits are zeros and ones. So we need 4 digits. and those digits must be zeros and ones, so that we can represent a number in base 16. So also, if you look at the octal is written as is in base 8, right? And 8 can be written as 2 exponent 3. Meaning that if you want to represent a number in base 8, you need 3 bits to represent a number in base 8 or in the octal notation. I hope that's good. And also, if we have the binary, binary means base 2. So 2 is the same as 2 exponent 1. Meaning we need just 1 bit so that we can represent a number in the binary notation. Okay, that's what it means. So it's very important that we understand these basics. We've solved some questions on this in previous videos on the channel. You can go through them. But we are about to solve more questions. We learn how to convert from different bases to the other bases. Now let's quickly wrap this up. So we've been made to understand that we are going to do mostly with just 4 different systems of notation. That is the binary, the decimal, the octal, and then the hexadecimal. Now the hexadecimal is base 16, and for base 16, 10 is written as A, 11 is written as B, up to F, which is written as number 15. Okay, yes. Now we also said that to represent the digits that are used to represent a particular number in a particular base always begin from 0 to 1 before the actual base we are working in. So for example, for base 16 we use numbers from 0 up to 15. For base 8 we use numbers from 0 up to 7. For base 2 we use from 0 to 1, and that's how we do that. For base 10 we use from 0 to 9. Okay, and we also know that we can convert from one base to another, just interchangeably like that. So this was just a very quick introduction to this, and we'll go ahead and solve more questions on this in subsequent videos. So thank you, all the best. Believe you can do it, never give up, and see you in the next video. Bye bye.